Section 3.1, challenge activity 3.1.5, using regression to make equations. So this is how we apply all the information that we've been looking at. The end game of linear regression is then to use it to make predictions. Financial advisor wants to determine how the amount of time spent on financial education affects the amount of debt. The idea is that if you educate people more hours spent, that their debt would go down. So here we see a negative slope, which is a good thing in this case. So we need to find that regression equation. So we first need to find the intercept. Here we know it's 5,000. So we already know we can use that as our 0.1 for our slope. So I'm just going to write 0 and 5,000. Might as well go ahead and put that here. 5, 1, 2, 3. And then for our slope, we need to find our 0.2 somewhere else on the line. Oh, here's a nice little intersection. So here we've got x is 20. And here we have 40,000. Oops, excuse me. I wrote 5,000. It's 50,000 and 40,000. Okay. And I should make sure to type in an extra 0 there before I get that one wrong. Okay. Pay very close attention to your number of zeros. So remember, our slope is our rise over run. That's going to equal y2 minus y1 over x2 minus x1. So here's our y2 is 40,000 minus our y1, 50,000. Again, we already know right there that's going to give us a negative number, which matches up with the negative slope we're seeing. So then we have x2, 20, minus x1, 0. Then we have negative 10,000 over 20. And that gives us negative 500. All right, so let's go put our slope in as negative 500. Check. All right, that was correct. So again, pick 2 points, subtract the y2 minus y1, divided by x2 minus x1, and then our intercept is just whatever that y value is when x is equal to 0. Let's go next. All right. Looks like we're looking at the same plot. The financial advisor wants to determine how the amount of time spent on financial education affects the amount of debt. Good thing we already found our little regression equation. It says a financial education time of 27 hours is found to result in an amount of debt of $36,500. That's the data point. So that's going to be one of those little blue dots. What is the predicted amount of debt? So we're asking, what then would our regression line predict? What would, where would that fall on that line? So that means what we need to do is plug in 27 for our x. So let's go ahead. Let me write this out, and then I'll show you guys the screen in a second. Y hat equals 50, 1, 2, 3, 50,000. Sorry, I count my zeros. Minus 500x. And we're looking for when x is equal to 27. Okay. So I have my regression equation here is 50,000 minus 5x. The way they wrote it is plus negative 500x. But remember, when you have a plus and negative, it's the same thing as saying minus. So minus 500x. And we're looking for what our equation is going to predict when x is equal to 27. So that means we need to plug 27 in for our x. All right. So that gives us 50,000 minus 500 times 27. So let's go ahead and put that in. Those are some not nice numbers. So we're going to say 500 times 27. All right, so that gives us 50,000 minus 13,500. And when we subtract that, we get 36,500. All right, so let's come back over here. So 30. All right, so where's the observed value in relation to the regression line? It's on it, it looks like, because it's saying that it observed 36,500, and then we found through our calculation that the predicted amount was 36,500. All right, so it's on the line. Now, one thing you'll more often than not see is that it'll be on below or above. And I'm thinking we'll see that in the next couple of steps. So a financial education time of 24 hours is found to result in an amount of debt of $41,377. What is the predicted amount of debt? So let's do the same thing we did over here, but now we're doing it for 24 hours. So let's erase some of this and just put in our 24, make our life a little easier. 24. All right, so let's say 500 times 24 gives us 12,000. And then that's going to give us 38,000. So let's go back over here. So the predicted amount would be 38,000. And it says, where is the observed value in relation to the regression line? Well, the observed is 41,000. The predicted amount is 38. So it is above the regression line. That would mean that if we were to plot it over here, we would see it up here above the line. A financial education time of 18 hours is found to result in an amount of debt of 39,707. What is the predicted amount? Again, we're going to come back over here. We'll just erase some of this again. What did it say? 18? Yeah, 18 hours. 18. Oops, let's erase this too. So we have 500 times 18. That's going to give us 9,000. So 50,000 minus 9,000 is 41,000. So let's put that over here, 41,000. And it predicted, so our predicted amount is 41,000. The amount of debt is 39,000. So that means it's below. That would mean if the data point was down here, it would be down here below the line. All right, let's check. Oops. Set an answer for each input. Looks like I'm not allowed to put those commas in there. That was my mistake. All right, let's check. All right, that's everything. So again, my bad about the commas. So be careful with how you input your answers in here. All right, so the idea is that when you want to find what the predicted amount is, you take the x value and you plug it in for x and you see what comes out for y hat. And then you can use that to compare your actual observed values versus your predicted amount. But the main idea is that once you have this regression line that you think fits your data well and you think is a good tool, you would then use it on future data. So for example, let's say I have this class of new financial students that I just educated and I talked about how many hours I spent educating. I could then make a prediction for how much I think their debt would be based on the number of hours they had in education and financial security and whatnot. All right, let's go to the next section. If it'll let me click on next. Oh, there we go. All right. A medical researcher wants to determine how a new medication affects blood pressure. Here's our line. Again, we see a negative slope, which is good. So the amount of medication and the patient's systolic blood pressure. So you would hope that as they take more medication, their blood pressure goes down, which is good. For an amount of medication of 198 milligrams, the blood pressure is observed to be 122.81. 122.81 is below the regression line. So the residual for this observation is negative, positive, or 0. Remember, when you take the residual, you're looking at the observed value minus the data line. So in this case, it would be, if it's below, it would be negative. So let's check. Exactly. It's below the regression line, so the residual is negative. Let's go to the next. A medical researcher wants to determine how a new medication affects blood pressure. Same thing. We're given the equation of the regression line as y hat equals 140 plus a negative 0.0667x. Can this regression be used to predict blood pressure when the amount of medication is 350 milligrams? Our option is yes, no. Well, that one's kind of a tough one. We can use it, but with caution, because see how the model data ended up here at 300, and it went from what is this? About 20 or so. So it's really might be outside of the scope. So we would say in this case, no, because the data values were not covered during the development. It's not a good idea. So we would say no. Check, yes, because it's larger than any data points used. Now, I just want to iterate, or not reiterate, but add on to that a little bit. In the real world, we might have to use this model on values that were not used in development. Not always, but sometimes. But it's never done without caution and lots of checks and things like data validation, model validation. It's not recommended, but in some cases, there's some business needs where you might have to. So I just want to make sure that's clear, that if you end up in a business environment and something like this comes up, you might see that where you say, well, I learned in statistics we shouldn't do that. But it is possible. It's just not done without extreme amounts of caution. All right, so if you have any questions about that or anything else in 3.1, let me know.